We're going to talk about 3-2 logarithmic functions today. And what I want to do is refresh your memory about 3-1. And in 3-1, we introduced the, let's say 3 to the x power, which was called an exponential function. Okay? I want to take the inverse of this thing. Because what we're going to start getting into is this. How do you find out what x would be? And we can kind of look into the future a little bit. An example problem might be this. 2 to the what power is equal to 99? Right? Or say, I know 2 squared is 4, and 2 cubed is 8, and 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. So what I know here is this. Okay, what we remember is 2 to the 6th is equal to 64. You might even know 2 to the 7th is 128. So would you agree that x is going to be somewhere between 6 and 7?
Yeah.
Okay?
Maybe.
Because 2 to the 6th is 64, and I want to get 99. It's going to be somewhere between 64 and 128. How do you solve for x in this case? You have to convert to a logarithmic function. We'll get to it later, but I just want to show you what we're trying to do with this. This is like a look into the future in 3-3 and 3-4. A conversion factor is to say, I need to get the x out of the exponent. I need to get the variable out of the exponent in order to find out what that exponent might be. Now you can use trial and error all day using your calculator, but what number is going to give you exactly 99? Nobody knows for sure. I know it's going to be between 6 and 7. Our job is to find it eventually. If I gave you y equals 3 to the x in 3-1, I can talk to you about the inverse of that function. Now let's go back to Algebra 1 very quickly. If I give you x minus 3, what is the inverse? X plus 3, right? If I give you 12x, what is the inverse? X divided by 12, because it's the opposite function, right? Or if I give you the square root of 10, what is the inverse? 10 squared, right? It is all the opposite functions of what we're looking for here. And if I give you y equals 3x, the inverse is something called log, lowercase letters, L-O-G. And in this case, my base is 3, because that's the number that I'm raising to a power. And in this case, my base is 3. Your log is also going to have a little tiny subscript of a 3, and that's the base. And in this case, if I have y is equal to 3x, the inverse is log base 3 of x is equal to y. Log base 3 of x is equal to y. And here's the general box here. Let me give you the general form for all bases, not just log base 3 or log base 10. And where does log actually come from? Log base 10, which is what the key in our calculator is going to be. What if you type in your calculator second log? What comes up? 10 to the x power, right? Because in 10 to the x power, 10 is going to be my base. So log base 10 and 10 to the x power are inverse functions of each other. So here's the general box here. If I give you, and I'll do this the way the book does, log base a, could be any number. Usually it's going to be whole numbers like 2, 3, 4, 5, 6, 7, 8, 9, or 10. Log base a of x is equal to y means the following function. What I can do is say that a is my base, so this is going to be base a. Logs are equal to the exponent, so my exponent is the y power, and that's equal to my value x. That's what it means. They are just inverse functions. When you were sitting around in 7th and 8th grade and they were introducing to you a square root function, right? It's scary, right? Because we've never seen it before. I don't know what the square root means. What is a radical? right? And now it's the same, except it's just the inverse of an exponential function is something called a log. Now, I want to practice some of these in our head. But first, let me give you this written as a function. F of x equals log base a of x is a log function with base a. The base is a, or the base is 10, or the base is 3, or the base is 5. All it does is change the steepness of the function. Okay? And I want to give you the quote here. The quote is this. This is what you're going to ask yourself. Quote, to what power must a be raised to obtain x? Question mark. Now most of these, especially the ones at the beginning, you can do in your head because we know most of our powers. Our squares and our cubes and our halves and our thirds and our zero powers and our negatives. Okay, they're really easy to do in our mind. Some of them will require a calculator. Alright, so let's practice some of these here. Let me give you a function of x, and let's call it log base 4 of x. Okay? What I want you to do is to find f of 16. And I'm going to ask you this question. The question that's in the quotes. To what power must a be raised to obtain x? Or to what power must the base be raised to obtain x? So how this is going to be written is this. If I find f of 16, I want to find log base 4 of 16. All I did was take the 16 and plug it into the function, right? All I do is take the 16, plug it in the function. To what power must the base 4 be raised to obtain 16? 4. 2. Because 4 squared is 16. Okay? To what power? Because remember, logs are equal to the exponent. The corresponding equation to this is 4 squared equals 16. I don't have to write this. I just know where this log comes from because when I convert back to an exponential, I know that they're converted because they're inverses of each other. Let's do g of x this time. G of x is log base 9 of x. And I want you to find g of 1. G of 1. What does g of 1 mean? Log base 9 of 1. Now we're going to do this in our head. To what power must the base 9 be raised to obtain 1? What? 0 is right. Why? Because 9 to the 0 power is 1. Anything to the 0 power is 1. So whenever I have a log of any base of 1, it's going to be equal to 0 because any base to the 0 power is equal to 1. Okay? F, G, H. Let's do h of x this time. I'm just going to do this in our head. H of x is equal to, let's do log base 3 of x. Okay? I want you to find, in your head, h of 81. H of 81. Now, what is h of 81? H of 81 means log base 3 of 81. I just take the number and plug it in. Let's think. To what power must the base be raised in order to obtain 81? Well, 3 to the what power is 81? 4. Because 3 times 3 times 3 times 3 is 9 times 3 times 3, or 27 times 3, or 81. Fair enough? Last one, and then we'll move on to some graphs and some calculator work here. F, G, H, I, let's do j of x. J of x is log base 2. Log base 2. Let's do a tough one. No calculators allowed here. I wouldn't even know how to use the calculator if they were allowed. Let's do j of 1/8. What does this mean? This means I want you to find log base 2 of 1/8. And you ask yourself this question. To what power must 2 be raised to obtain 1/8? What does this mean? 2 to the what power is 1/8? I mean, it's the same way we did this over here. 4 to the second power is 16. 9 to the 0th power is 1. And 3 to the 4th power is 81. 2 to the what power is an eighth?
-4.
Close. -3. Why? What does 2 to the -3 mean? It means I take the negative power, put it on the bottom, right? Doesn't this become 1 over 2 to the +3? And what is 2 cubed? What is 2 cubed? 8, so this is equal to 1/8. So this is equal to -3. That's really as tough as it gets. Remember, negative exponents go down onto the bottom. Okay? Take out your calculator for a quick sec. Alright? Can you find your log button? The problem with the calculator is this. You cannot change bases with the calculator. Okay? So if I ask you to find log base 4 and log base 9 and log base 3 and log base... You can't do these on the calculator because log on the calculator is always base 10. Because if I do second log, it's 10 to the x power, right? So f of x, sometimes what we can do is just leave the 10 off. If I just say log of x is log automatically base 10. Right? Like if I say p. Okay, what is in front of that p? 1. Automatically, all the time. What is on the bottom of that p? 1. Automatically, all the time. What is the exponent on this p? 1. It's p to the first power, right? Automatically, all the time. What is the base of this log? 10. Automatically, all the time. So right here on your calculator it says log. That is always, all the time, every time, base 10. And that originates back to the fact that we have 10 fingers. That's why we have base 10. Right? If we only had, like if we were the Simpsons, we had 4 fingers in each hand, like 3 fingers and a thumb. Right? And then we would be in base 8 because Simpsons only have 8 fingers. That's where it all comes from. Say 1, 2, 3, 4, 5, 6, 7, 10. There's no 8 or 9 because they only have 8 fingers. It's the Simpsons. We have 10 fingers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go to 10. Because there's no symbol for 10. It's a 1 followed by a 0. A 1 followed by a 0 means 10, but it's really using the numbers 0 and 1. Or 1, 0 means 10.
Alrighty then.
Let's use our calculator to evaluate f of 10. F of 10. So let's just type in our calculator, log 10, enter. Tell me what you get.
1.
1 is right. Why is it 1?
Yeah.
Because 10 to the first power is 10. So it's equal to 1. 1. Let's find f of 50. Well, what do I do here? I just type in the calculator, log 50, enter.
1.699.
Is it 1.699?
Yeah.
Sure.
1.6997?
Well, it's 1.69897.
Okay, let's call it 1.699. Right? 1.699. What does this mean to you? 10 to the 1.699 power is equal to 50. Okay? F of 1/3. Type log 1/3, enter.
Negative 4.77.
Okay, negative 0.477. Negative 0.477. Technically, we need the approximately equal to sign because it's not exactly equal to that because everyone in this class is rounding.